Okay, this is Mr. Wyrick, and I'm here to talk to you about today's notes real quick. We are simplifying some expressions with fractions and stuff like this. Simplest form is the most reduced fraction. And that's going to also include your exponents. So you have to reduce those as well. If we go to simplify this, a negative 27 divided by 9 is going to be a negative 3, and that would be above the fraction line. 27 divided by 9, negative 3. X to the third over x to the fourth. When we're dividing, we subtract those exponents. So 4 minus 3 is 1. The bigger one was on the bottom. It keeps an x on the bottom. Y divided by y is just 1, so we're here. A negative 3 over x. On this one, we have a negative 3x plus 6 over x squared minus 6x plus 8. We factor the top, we have a GCF. That's a negative 3 times x minus 2. On the bottom, we have x squared minus 6x plus 8, so that's going to be an x minus 2 times an x minus 4. Those will add together to give us the negative 6, multiply together to give us the positive 8. Since we have the exact same factor, complete, top to bottom, we can actually get rid of that x minus 2 top and bottom, and that leaves us with negative 3 over x minus 4 as my simplified form. On this last one, I'm going to do the same kind of thing. I'm factoring. I've got 2x, and I've got x. It's going to multiply to a negative 2, add together to a negative 3. So this is going to be a negative 2 over here and a positive 1 right here. That would give me a negative 4 plus 1, which is a negative 3 in the middle, and 1 times a negative 2 is a negative 2. On the bottom, I've got x squared minus 5x plus 6. That's an x minus 2 and an x minus 3. I can cross out those x minus 2's. They match up. So I've got 2x plus 1 over x minus 3. I'm reducing the fraction as much as I possibly can. When we talk about domain restrictions, it's anything x cannot be. Now this is determined by the bottom of the fraction, the denominator, and it's any time that denominator would end up being 0. If the denominator equals 0, that's a limitation to our domain. So if we go back and look at our domain restrictions, it's tough to say on number 1 because of the y, but anytime x equals 0, we can't do that. So x cannot be 0. On our b, we have the x minus 4 and the x minus 2. Even though they match up top to bottom, it still factors into our limitations of our domain. So that's x cannot be 2 or x cannot be 4, because 4 minus 4 would be 0. We'd end up with 0 on the bottom. On letter C, we've got that x minus 2 and x minus 3 in the factored version. X cannot equal 2 or 3. So any other questions that say divide on today's paper, kind of skip over those. We'll go back over this. We'll look at some examples on Tuesday. We'll keep working it. But for Monday, we are going to multiply. So that means I'm just going to go ahead and work problem B over here. But the a squared minus 4 is going to be a plus 2 and a minus 2. The a squared minus 1 is going to be a plus 1 and a minus 1. That's difference of squares that I'm factoring there. And I'm multiplying that by a plus 1 over this a squared plus 2a is going to be a times a plus 2. So my a plus 2's match up and my a plus 1's match up. So I have a minus 2 over a minus 1 times a. You can leave it in a factored form, and then my restriction on that variable, a cannot equal, and I have to go back to my factored version. So it can't be positive or negative 1, it can't be 2, and it can't be 0. Very important, get all of those from the factored form. Same thing here, this would be x minus 4, x plus 3. This would be x plus 3 and x plus 1. I'm multiplying that by x plus 1 and x minus 1, and then this is just an x minus 4 on the bottom. Everything that matches up, the x minus 4's, the x plus 1's, the x plus 3's, all cancel out. So the simplified one is x minus 1. But if we did go back and graph this, we'd notice some holes in the graph at x cannot equal, the +3 would be a -3, the +1 would be a -1, and the -4 would be a +4. If you have any other questions, touch base with me. Make sure you ask those questions when we come back to class.